Alright, let's look at practice exam 3, problem number 5, part B. Alright, so we want to take this limit. Alright, so first thing we do is we're going to try to use this trick to make this look a little bit more like L'Hopital's rule. Alright, so we can write it as, let's see, so limit, we still have a limit. As x approaches infinity. Right, then we can put e to the natural log. Right, remember that the exponential function and the natural log functions are inverses of each other. They basically cancel out. So we apply that to quantity 1 plus 1 over x. Raise it to the x, right? And the good thing about this is that we can use one of the log property. So if you have a power here, right, you can put it in front right here, right? So let's do that first. So this is going to be equal to limit as x approaches infinity. Right, so you have a e to the x natural log of quantity 1 plus 1 over x. Right, then the next step would be instead of multiplying by x, we need a fraction so that we can apply L'Hopital's rule. And one way to do that would be instead of writing x multiply by x, which is the same thing as dividing by 1 over x, right? Multiplying by x is same thing as equivalent to divide by its reciprocal, right? All right, then the next step would be, all right, so we're going to put the limit in here. So it's going to be e is just a constant, right? Then put it here, so you have a limit as x approaches infinity. Then you would have natural log of 1 plus 1 over x over 1 over x. Right? Then you can see that this is going to be a L'Hopital's rule, because here as x approaches infinity, 1 over infinity approaches 0. Right? Then you have natural log of 1 plus this approaches 0. Natural log of 1 is also 0. Right? So you have a 0 over 0 situation. So we can apply L'Hopital's rule. Right? Now we can apply L'Hopital's rule. Right? So you have e to the limit as x approaches infinity. Right? Then we take the derivative of the bottom, right? Derivative of 1 over x is negative 1 over x squared, right? We can do that, right? Because 1 over x is the same thing as x to the negative 1 power. So if you take the derivative of that, put the negative 1 in front, x, subtract 1 from the power, so it's negative 2. Which is 1 over negative 1 over x squared, right? Then here, if you take the derivative of natural log of something, remember that when you have, say, natural log of, say, g of x, right? And the derivative is simply put whatever inside the natural log, put it on the bottom, and to take the derivative, put it on top, right? So derivative of natural log of 1 plus 1 over x would be, right? So put whatever inside, so it's a 1 plus 1 over x on the bottom, and take the derivative of that, put it on top. So derivative of 1 is 0, so I'm not going to write anything there. Derivative of 1 over x, we just talked about it, negative 1 over x squared. Alright, then you can see that we can cancel negative 1 over x squared. There's negative 1 over square on top, right? Then you can clean it up. So this is going to be just e to the limit as x approaches infinity. Then you just have, so this canceled out, so you have 1 on top. Then you have 1 plus 1 over x. Alright, then we can just take the limit. So as x approaches infinity, 1 over x approaches 0. Right, so you would have 1 over 1 plus 0, which is going to be 1. So therefore this will give you e to the 1, which is just going to be e. Alright, so the limit is actually e. Alright, that's it. I hope that this was clear.